Hi everyone, you are welcome to my YouTube channel once again. Now today we are going to be looking at chord. By the way, this is Mass Physics Made Easy by Engineer Emmanuel Sinoba. If you have not subscribed to my channel, do me a favor to subscribe. The only favor you can do for me in this that I'm helping you out with is to subscribe to my YouTube channel. It costs you nothing. It costs nothing just to subscribe. Hit the subscribe button and the notification bell in order to get notification anytime I upload a new video, okay? All right, now let's move on immediately. Now today we are going to be looking at a chord, assuming that this is a circle and this is our center of the circle. All right, what is the meaning of a chord? Apart from diameter, which is the chord that divides the circle into two equal halves, we are going to be looking at mainly other chords. Okay, let me produce a straight line here. Any line that cuts the circle into two parts, any line that cuts the circle into two parts is called what? The chord. Now this is the chord. All right, now if you look at this, you discover that this is the center of the circle. Assuming I take down my radius down to here, take down my radius also down to here, this will be radius, this will be radius. There is something you will notice here. You will notice that I just produced a triangle and also a sector. Look at that, a sector and also a triangle. That's to tell you that in chord there is a relationship between triangle, that is trigonometry, and what? This topic. There is no special formula as an accrued to this topic like that. The only thing is that any question that is being given requires your knowledge in trigonometry for you to be able to solve it. And the main thing that matters is that all these things are very simple. Now from this center, I can draw another straight line down to here. This straight line you see that I've just drawn now is known as the height. That is the height of the triangle. So having known this, let's quickly look at example. The first example we are going to look at here says, example number 1. A chord AB of a circle of radius 10 cm subtends an angle of 60 degrees at the center of the circle. Find the length of the chord. Now let's quickly put down solution to this question. Solution. Now look at what you're going to do. A chord AB of a circle. Draw the circle first. Draw the circle. Now a chord AB, just, you know, your chord can be represented anywhere you like, up or down, but mostly we represent it down. Draw a chord AB. Substance, okay, a chord AB of a circle of radius 10 cm. Now point your center, bring this down to touch that line, call it 10 cm. Bring the other one again, because if from here to here is radius, equally from here to here again is radius, we also have 10 cm. All right, now it subtends an angle of 60 degrees at where? The center. So we put 60 here. Are you seeing what is happening now? So they now told us find the length of the chord, which is this chord AB. Now when you look at this, you discover that this has formed a triangle. If I like, I will put O here, call it triangle AOB. All right, it has formed a triangle. So what we are going to do is to do what? Slash out this triangle and define the length from here to here. Look at how we do it. Let me quickly slash out the triangle. Look at the triangle there. Let me quickly slash it out. So 10 cm, 10 cm, 60 degrees. Do you see it now? Now we are being told to find AB, the length from here to here. Do you know what you are going to do? It's very, very simple. Just do what? Cut the triangle into two. When you cut the triangle into two, use 1 for your calculation. So look at it now. I cut 1 out. Okay. So I may decide to put X at the center so that I will have XB. All right. Now, as I have cut this at the center now, it simply means that this 60 will become 30. to become 30. All right, and this place will still be 10 cm. Do you know the trick I am going to use now? If I find xb, whatever I find here, if I multiply it into 2, I get the length from A to B. That is the length of the chord. If what I found here was 4, I will say 4 plus 4, because whatever that is here must be whatever that is here. Forget my drawing. You must, the triangle have to be equal in size. All right, so that is how we do it. This is a right angle triangle. So watch it now. From here now, we are looking for our xb, and look at our angle. This xb you are seeing now becomes the opposite to this angle, which is 30 degrees. The place that the angle is looking at, as if it is human eye, the place is facing, they always call it opposite. The slanted place is called hypotenuse, and the remaining side is called adjacent. So what you are now going to do here is to look for relationship that connects opposites and the place you have value, which is 10, which is your hypotenuse. Now when you put down you begin to search. This one says sine equal to opposite over hypotenuse, which means it connected opposite and hypotenuse. So we are going to use sine. Therefore, we say sine, immediately you write sine, you put down the angle. Sine of your angle 30 is equal to opposite, which is your xb, opposite to the angle, over hypotenuse, this place 10. All right, now look at what you are going to do. Put 1 here to solve it normally. Now cross multiply xb times 1, you get what? Xb is equal to 10 times sine 30, which is 10 multiplied by sine what? 30. My dear, when you punch sine 30 in your calculator, it is going to give you 5. So it is going to give you 0.5, sorry. So you now say 10 times 0.5, which is now equal to 5 cm. So our xb is what? 5 cm. But actually we have found xb, but what we are looking for is ab. So here is 5 cm, here will now be 5 cm also, which means that our ab, are you there with me, will now be equal to 5 cm times 2, which is 10 what? Cm. So finally the length of the chord is 10 cm. Is this not simple? Is this not simple? Now let's quickly look at another example. Finally, example 2. Example 2. Now example 2 now says a chord of a circle, a circle has a length of let's say 4 cm from the center of the circle. If the radius of the circle is 5 cm, find the length of the chord. Find the length of what? The chord. Now watch the question. A chord of a circle has a length of 4 cm from the center of the circle. If the radius of the circle is 5 cm, find the length of the chord. Now when we put down solution, the best approach to all this, anything concerning circle, is to draw the circle. That's the best approach. If you don't draw the circle, you may find it very hard, not only hard but very hard to solve that question. Now a chord of a circle, immediately any day you are reading something and you hear circle, before attending to the question first proper, you draw a circle and look at what he's saying. A chord, you heard chord, cut your circle into 2. All right, now a chord of a circle has length of 4 cm from the center. Point your center. Look at your center here. From there, come down to that chord perpendicularly. That is that 4 cm they are talking about. All right, from the center. Now, okay, what is it saying now? From the center of the circle, if the radius of the circle is 5 cm, watch it now. Radius 5 what cm, 5 cm. Here also will be 5 cm. Forget my drawing, you understand what I'm saying? It's because of this 4. Okay, now let me clean it and put it down very well. 4 cm. Okay, all right. Now if the radius is 5 cm, find the length of what? The chord. Do you know what? How we are going to solve this one? Bring out that triangle again. Slash out one triangle of your choice. Now let me name the place XY. Okay. Now look at what is going to happen. Here is 4 cm, while here is 5 cm. If I like, I can name this place A. So here we now become AY. Okay. So if I find here, I multiply it by 2. Whatever I get will become the length of the chord. Is this not simple? Now watch it now. Watch it very well now. Watch it very well. Now the triangle I slashed out is this. 5 cm, 4 cm, and AY. Okay. Now for us to get this place, if you are very good with trigonometry, you discover that 2 places are given, remaining 1 place. We are going to use Pythagoras theorem. Pythagoras theorem. Pythagoras theorem. Now, when I enter trigonometry, I am going to treat all these things one after the other, but you can learn it here. Now, using Pythagoras is a theorem that is used to find the remaining place in any triangle when 2 places are given in right angle triangle only. Any right angle triangle, when 2 places are given, remaining 1 place. All right, that is another solution apart from SOHCAHTOA. Okay, now what does it state? It states that the square of the longest side, look at the longest side here, the square of it, 5 square, is equal to the summation of the squares of the other 2 sides. So we can say is equal to 4 square plus summation of the squares of other 2 sides, AY squared. That is what Pythagoras says. Now look at what happens. 5 square will give us 25 is equal to 4 square is 16 plus AY squared. All right. Now, according to linear equation, draw 16 over to this side. It becomes 25 minus 16 is. All right. So 25 minus 16 will be equal to AY squared. Okay. So 25 minus 16 will give us 9, which is equal to AY squared. Now transpose it. We have that AY squared is equal to 9. Therefore, our AY will be equal to square root of 9. When square crosses over, it becomes square root of 9, which is now equal to 3. In this case, it becomes 3 cm. Our AY is 3 cm. But to get our XY, it is now going to be times 2. XY will now going to be 3 times 2, which is what? 6 cm. Subscribe to my channel. Okay, subscribe. See you later. Thank you very much.